Here's how to find the area between two curves. So here we have two functions, and they're asking us to find the area of the region enclosed. Now, if we had access to Desmos or a graphing calculator, we could just graph these two functions, and the area in between would be this shaded region. However, I'm going to show you how to do this without ever even needing to know what the graph of the functions looks like. The general strategy is to take the integral from a to b of the top function minus the bottom function. So the first thing we need to do is to figure out what our endpoints a and b are. These endpoints are going to be where the two functions intersect. So what I'm going to do is set these two functions equal to each other. Now I'm going to simplify by putting all the x's on one side, and now I notice this is a quadratic that I can just factor into x plus 6 and x minus 1. So my intersection points occur at -6 or 1. And these are our endpoints. Now what we need to do is determine which function's on the top and which function's on the bottom. In order to do that, I'm going to pick an x value in between my two endpoints. In this case, I'm just going to choose 0, and then check to see which one has the higher value. The first function comes out to be -1, whereas the second function comes out to be +5. Since this second function has a greater value of y at the point 0, that's going to be our top function. And y equals x minus 1 is our bottom function. So now what we do is we plug our endpoints into our integral. Always make sure you're going from the smaller endpoint to the bigger endpoint. And then we plug in our top function minus our bottom function. Now we're going to simplify a little bit and evaluate the definite integral, which gets us this. So now plugging in my endpoint 1, I get 19/6. And plugging in our other endpoint, -6, I get -54. And now subtracting the two, I get the final answer, which is 343/6. And there you have it. That's how to find the area in between two curves.
Nice!